A magnitude 5.1 earthquake shook the San Francisco Bay Area today. It was the strongest they've seen in 8 years. It was centered in the hills east of San Jose, about 40 miles southeast of downtown San Francisco.
The ground beneath the Bay Area isn't just rumbling, it's sending a warning. A cluster of earthquakes has shaken San Francisco and surrounding cities, leaving residents on edge and experts scrambling for answers. Is this just typical seismic activity, or the foreshock of something bigger? Scientists are monitoring pressure buildup along major fault lines, and early data suggests unusual patterns that could point to a larger quake looming. What's causing this sudden spike? And is San Francisco at risk for the big one? Let's break down what we know, and what's still uncertain, about these unnerving quakes rocking California's most populous region. Earthquakes in the San Francisco Bay Area. What's going on? In the San Francisco Bay Area, earthquakes are not a rare occurrence. They are a regular, ongoing part of life. Beneath the surface of this densely populated region, powerful geological forces are constantly at work. The ground shakes frequently, often without notice, but sometimes with devastating consequences. San Francisco, Oakland, San Jose, and surrounding cities sit atop one of the most seismically active regions in the United States, if not the world. This reality has shaped not only the landscape, but also the lives of those who call the Bay Area home. Understanding why these earthquakes happen so frequently, and what can be done to prepare for them, is essential for every resident. The reason behind the Bay Area's frequent seismic activity lies in its geology. This region sits directly along the boundary between the Pacific Plate and the North American Plate, two massive tectonic plates that are in constant motion. The interaction between these plates creates faults, which are fractures in the Earth's crust where pressure builds as the plates grind against each other. One of the most infamous of these is the San Andreas Fault, which stretches over 800 miles through California, running straight through the Bay Area. Other significant faults in the region include the Hayward Fault and the Calaveras Fault, both of which also contribute to the area's seismic volatility. As these plates move, stress accumulates along the faults. When the pressure becomes too great, it is released in the form of an earthquake. According to the United States Geological Survey, USGS, the San Francisco Bay Area experiences roughly 5,000 earthquakes each year, though most are too small to be felt by people. Nevertheless, the sheer volume of seismic activity highlights the constant movement beneath the surface. Occasionally, larger quakes strike, shaking buildings, rattling nerves, and sometimes causing severe damage. The 1906 San Francisco earthquake, with an estimated magnitude of 7.9, remains one of the most destructive natural disasters in American history. It devastated the city, causing widespread fires, collapsing structures, and claiming thousands of lives. Though over a century has passed, that event serves as a stark reminder of the power of these geological forces and the importance of preparation. California, as a whole, is no stranger to earthquakes. The USGS estimates that the state experiences around 10,000 earthquakes annually, with most occurring in Southern California. However, the Bay Area remains at significant risk due to its proximity to major faults and its dense population. The California Department of Conservation reports that the state typically experiences 2 to 3 earthquakes per year that are large enough to cause moderate damage, generally those that measure magnitude 5.5 or higher. Given that the Bay Area is located on several active fault lines, the likelihood of experiencing a damaging quake is higher here than in many other parts of the country. The frequency of earthquakes in the Bay Area is part of a global pattern. The USGS identifies 3 major seismic zones worldwide: the Pacific Ring of Fire, the Mid-Atlantic Ridge, and the Alpide Belt. The Ring of Fire, which includes California, accounts for about 81% of the world's largest earthquakes. It encompasses the rim of the Pacific Ocean and is known for intense geological activity, including both earthquakes and volcanic eruptions. The Mid-Atlantic Ridge and the Alpide Belt also experience frequent seismic events, but due to their location, they generally pose less of a direct threat to California. What makes the Bay Area unique is its location at the intersection of these global geological forces. placing it in a perpetual state of seismic tension. Given this level of risk, residents of the Bay Area must remain prepared. Earthquake forecasting remains an inexact science. Scientists cannot predict when or where the next big quake will strike. However, they can identify high-risk areas and offer probability estimates for significant seismic events over certain timeframes. These estimates, combined with public education and infrastructure planning, can mitigate the effects of earthquakes and save lives. Living with risk, preparation and resilience in earthquake country. Although the San Francisco Bay Area is no stranger to earthquakes, the question remains, how can residents protect themselves and their homes from the next major quake? The answer lies in preparation, both at the individual and community level. While scientists cannot forecast earthquakes with precision, they can advise on steps that significantly reduce the risk of injury, death, and property loss. In a region where earthquakes are inevitable, preparedness becomes a way of life. One of the most effective ways homeowners can safeguard their property is through seismic retrofitting. This process involves strengthening a building's structural integrity, particularly the foundation and framing, to withstand the shaking caused by an earthquake. Older homes, especially those built before modern building codes were in place, are particularly vulnerable to damage. Retrofitting can prevent collapses, reduce repair costs, and most importantly, save lives. Various programs across California offer financial assistance and grant funding for retrofitting, helping homeowners make these critical improvements without bearing the full cost. In addition to structural improvements, emergency preparedness is essential. Families should have emergency kits with food, water, medical supplies, flashlights, and other essentials to survive without assistance for at least 72 hours after a major quake. Developing a communication plan, knowing evacuation routes, and staying informed through earthquake alerts can also make a significant difference in the aftermath of a disaster. Community-level planning, including earthquake drills and public safety initiatives, further enhances resilience. Earthquake risks vary within California, but some cities face greater threats due to their location. In addition to San Francisco, Los Angeles and San Diego are both situated in high-hazard zones. Los Angeles, in particular, sits atop numerous active faults and experiences about 10,000 earthquakes annually, similar to Southern California as a whole. San Diego, while less seismically active than its northern neighbors, has seen increased earthquake activity in recent decades. The Rose Canyon Fault, running beneath downtown San Diego, poses a substantial risk, with scientists estimating it could generate earthquakes of up to magnitude 6.9. Despite these regional differences, California's vulnerability stems from its position along the Pacific Plate-North American Plate boundary. The constant movement between these plates generates immense stress in the Earth's crust. When that stress is released, the results can be catastrophic. The 1994 Northridge earthquake in Los Angeles, for example, caused billions of dollars in damage, killed 57 people, and left thousands homeless. Such events serve as reminders that while earthquakes cannot be stopped, their impacts can be reduced through foresight and action. It is also important to remember that earthquake risk is not just a local concern, it is a global issue. The Pacific Ring of Fire, stretching from the Americas through Asia and Oceania, affects millions of people worldwide. However, California's combination of active faults, urban density, and economic importance makes its earthquake preparedness a matter of national interest. As California continues to grow and develop, the challenge lies in balancing expansion with safety. New buildings must adhere to strict seismic codes, and existing infrastructure requires regular assessment and reinforcement. Public awareness campaigns, education programs, and government policies all contribute to a culture of preparedness that can minimize loss when, not if, the next major earthquake occurs. In fact, Southern California experiences an earthquake on average every 3 minutes. Tremors, both minor and significant, are part of daily life. Yet, what makes earthquakes in Los Angeles particularly unpredictable is not just the frequency of seismic events, but the way the city's unique geological structure influences the way earthquakes are experienced. Specifically, The vast, sediment-filled Los Angeles Basin plays a major and often underappreciated role in amplifying and altering seismic waves, sometimes intensifying shaking in one neighborhood while leaving others nearly unaffected. On 2nd March 2025, Hollywood's biggest stars had just begun arriving at their post-Oscar celebrations when a magnitude 3.9 earthquake jolted the area. Originating in North Hollywood at a depth of roughly 9 miles, 15 kilometers, the earthquake was not powerful by California's standards, but it was felt across multiple neighborhoods, and the shockwave caused high-rise buildings to sway and prompted brief panic among partygoers. Just a few hours later, a smaller 1.3 magnitude quake occurred in nearly the same location. No injuries or damage were reported, but the quake served as another reminder of how seismically alive the region remains. In the days leading up to the Hollywood tremor, seismologists recorded 36 earthquakes across the Los Angeles area, most measuring below magnitude 2.0, too small to be felt by humans, but notable as part of the constant seismic activity below the surface. On average, 15 to 20 earthquakes in Southern California each year measure above magnitude 4.0, enough to rattle nerves and cause minor damage. Earthquakes are expected here, but how they feel, whether they produce a subtle rolling sensation or sharp jolt, often depends on more than just magnitude or distance from the epicenter. The Los Angeles Basin, a massive, bowl-shaped depression filled with soft sediments, plays a crucial role in determining how seismic waves move through the region. This geological formation, stretching beneath much of the city, reaches depths of up to 5 miles, 8 kilometers, in places, and acts almost like a giant amplifier for seismic waves. Unlike hard bedrock, soft sediment allows seismic waves to slow down and grow in amplitude. As the waves become trapped in the basin, they bounce and reverberate, prolonging the shaking and, in some cases, increasing its intensity. This means that, during an earthquake, some areas may experience more violent and extended shaking than others, even if they are equidistant from the epicenter. For residents and city planners, this variability adds another layer of complexity to understanding and preparing for seismic events. A prime example of this basin effect occurred on 6 August 2024 when a magnitude 5.2 earthquake struck near Bakersfield, located at the southern end of California's Central Valley. Although the quake's epicenter lay 17 miles, 27 kilometers, south of Bakersfield, residents in Los Angeles, nearly 90 miles, 145 kilometers away, reported feeling the ground move. The shaking also reached San Diego, illustrating just how far seismic energy can travel through certain geological structures. The relatively shallow depth of the quake meant more energy was released near the surface, intensifying its impact in certain regions. Some parts of Los Angeles experienced prolonged shaking, while others remained almost entirely unaffected. The differences in experience were not random, but tied closely to how the seismic waves interacted with the sediment layers beneath the city. Just a few days after the Bakersfield event, Los Angeles was shaken again by a magnitude 4.4 earthquake, this time due to movement along the Puente Hills fault system, one of the most dangerous faults in Southern California. The quake's epicenter was just 4 miles northeast of downtown Los Angeles, yet, once again, reports of shaking varied widely across the city. People in some districts described sharp jolts and swaying buildings, while others felt nothing. Geologists point to the Los Angeles Basin as a critical factor, influencing these discrepancies. The sediment-filled basin can act as a channel, directing and sometimes trapping seismic energy, which leads to more severe effects in specific neighborhoods. How the Los Angeles Basin impacts earthquake experiences. The Los Angeles Basin does not distribute seismic energy evenly. Its shape and composition cause complex wave behaviors, including wave amplification, reverberation, and focusing effects. These phenomena result from the way seismic waves interact with sedimentary layers, which are less dense than solid rock, and allow waves to slow down while growing in strength. As waves become trapped in the basin, they bounce between layers of soft material, leading to prolonged shaking and, in some cases, more damage than areas built on firmer ground. This effect has major implications for urban planning and building design. Engineers and seismologists must take into account not just the proximity to fault lines, but also local geology when assessing earthquake risks. Buildings in areas where seismic waves tend to amplify and linger must meet higher structural standards to withstand increased shaking. The building codes in Los Angeles reflect this knowledge, requiring new construction to be earthquake-resistant, especially in regions prone to intense shaking due to basin effects. Understanding how the Los Angeles Basin alters earthquakes also helps emergency planners and first responders anticipate which areas may suffer the greatest impact during a major quake. By analyzing the geological features and historical seismic data, experts can identify high-risk zones and prioritize infrastructure upgrades and emergency response plans accordingly. This proactive approach is essential, especially in a city as large and populous as Los Angeles. The basin's impact was evident during past seismic events as well, including the 1994 Northridge earthquake, which caused widespread devastation across the San Fernando Valley. Though centered in Northridge, the earthquake's effects rippled through the Los Angeles Basin, amplifying shaking in certain areas while sparing others. This variation in damage puzzled many at the time, but has since been better understood through detailed geological studies of the basin's structure. Today, scientists continue to study the Los Angeles Basin using advanced seismology tools, ground motion simulations, and geophysical surveys. These efforts aim to refine earthquake predictions and improve public safety measures. Researchers use models to simulate how different magnitudes and fault ruptures might interact with the basin's layers, allowing them to forecast potential damage scenarios and provide better guidance to city planners, architects, and emergency managers. Despite these advances, earthquake prediction remains impossible. Scientists can estimate probability over timeframes, but cannot determine the exact timing or location of the next major quake. However, understanding the Los Angeles Basin's influence on seismic waves provides critical insights into risk mitigation. Residents are encouraged to take steps to earthquake-proof their homes, assemble emergency kits, and stay informed through local alert systems. Being prepared remains the best defense against the unpredictable forces beneath the surface. In summary, the Los Angeles Basin significantly alters the way earthquakes are experienced in the city. Its unique geological features can amplify, prolong, and redirect seismic energy, causing unpredictable patterns of shaking across the region. While recent quakes, including the March 2025 North Hollywood event and the August 2024 tremors, caused little damage, they serve as clear reminders of how the ground beneath Los Angeles constantly shifts, and how the sediment-filled basin plays a silent yet powerful role in every quake that passes through. Understanding this relationship helps scientists, engineers, and residents better prepare for future seismic events in one of the most earthquake-prone cities in the world. How seismic waves journey through California's landscape. At first glance, the ground beneath Los Angeles appears solid and unyielding, but beneath the surface, the Earth's crust tells a different story, one of fractured rock, shifting plates, and deep, stress-filled faults. These faults, which resemble the cracks in a shattered window pane, are where earthquakes originate. They form under immense pressure caused by the slow but relentless movement of the Earth's tectonic plates. In California, this tectonic dance plays out along the infamous San Andreas Fault, where the Pacific Plate grinds past the North American Plate at a steady pace of 30 to 50 millimeters, 1 to 2 inches, per year. Yet this movement is anything but smooth. The cracked, jagged rocks along the fault often snag against one another, sometimes remaining locked for centuries as tension builds between them. Eventually, this built-up stress reaches a breaking point. The rocks along the fault slip suddenly, releasing energy that had been stored for years or even millennia. This violent release triggers an earthquake, sending seismic waves radiating outward through the Earth. The rupture begins at a single point on the fault and can travel vast distances. In some cases, it stretches for hundreds of kilometers, with larger faults producing longer and more powerful earthquakes. The Great Sumatra Andaman earthquake of 2004, for instance, ruptured a fault line over 994 miles, 1,600 kilometers, causing one of the deadliest tsunamis in recorded history. Seismologist Lucy Jones, a renowned researcher at the California Institute of Technology, explains that the length of the rupture determines how much energy is released and how long the ground shakes. The longer the fault rupture, the larger and more destructive the earthquake. When a fault slips, the seismic energy propagates outward like ripples from a stone dropped into a pond, radiating in all directions. These waves move through various layers of rock and sediment, and their behavior is shaped by the geology they encounter. The magnitude of an earthquake measures the total energy released, while intensity refers to how strongly the ground shakes at a specific location. This intensity depends not only on how close someone is to the epicenter, but also on the direction of the rupture and the geological conditions underfoot. These factors explain why some people feel a quake intensely, while others, even just a few blocks away, might feel nothing at all. And this situation is only getting worse, as you will see later in this video. Recent earthquakes in the San Francisco Bay Area. March 17, 2025, 3.9 magnitude earthquake near Dublin. Jolts the Bay Area. On the evening of March 17, 2025, at approximately 7:46 p.m., a notable earthquake struck near Dublin, California, shaking the broader San Francisco Bay Area. Initially measured as a magnitude 4.2 event, seismologists at the U.S. Geological Survey later revised the quake's magnitude to 3.9 following further analysis. This adjustment is not uncommon, as initial readings often reflect preliminary estimates that become more accurate with the assimilation of additional data from regional seismic stations. The quake's epicenter was located about 10 kilometers beneath the surface, a depth of roughly 6.2 miles, which placed the event squarely in a seismically active region known for producing frequent but typically minor tremors. Residents across the Bay Area, spanning the South Bay, Peninsula, North Bay, San Francisco, and East Bay, reported sharp shaking that lasted for approximately 10 seconds. Although brief, the jolt startled many who described the shaking as sudden and forceful. Across social media and local news outlets, individuals shared their experiences, noting the immediacy with which the quake was felt. Despite the widespread perception of shaking, no significant damage or injuries emerged in the immediate aftermath, a fortunate outcome for a region historically vulnerable to seismic disruptions. In the hours following the main event, the U.S. Geological Survey recorded a series of aftershocks, which are smaller tremors that occur as the Earth's crust adjusts to the changes caused by the initial earthquake. One notable aftershock occurred at 4:46 a.m. UTC on March 18th, registering a magnitude of 2.9 and occurring at the same depth of 10 kilometers. This aftershock, while weaker than the main tremor, was still strong enough to be felt locally. Just 4 minutes later, at 4:50 a.m., another tremor measuring 2.4 in magnitude struck the same area. Earlier that day, at 3:10 a.m., a 2.2 magnitude quake had also occurred in close proximity to Dublin. These aftershocks are typical in active seismic zones, especially following a moderate event like the 3.9 magnitude quake near Dublin. Earthquake Track and San Francisco Chronicle both reported on the sequence of these aftershocks, noting the predictable pattern of seismic activity following the main rupture. March 10, 2025, 3.7 magnitude earthquake rattles San Francisco's coastal region. Just 1 week prior to the Dublin earthquake, on March 10, 2025, residents of San Francisco woke to a 3.7 magnitude earthquake that struck just off the city's coast at 7:02 a.m. The quake's epicenter was located approximately 5 miles southwest of the Golden Gate Bridge and just 2 miles west of the Great Highway. Though relatively moderate in magnitude, the early morning timing of the tremor, combined with its coastal proximity, ensured that it was widely felt across the city and surrounding areas. The shaking caused minor disturbances in homes, such as dishes rattling and light fixtures swaying, but did not result in any injuries or structural damage. CBS News covered the event, emphasizing the community's general readiness and rapid response to such tremors, which have become a familiar part of life in the Bay Area. The earthquake generated at least 2 aftershocks later that morning. At 9:39 a.m., a 2.5 magnitude aftershock occurred, followed by a slightly stronger tremor of magnitude 3.0 at 10:48 a.m. Both aftershocks originated from the same location as the initial quake and were felt across parts of the Bay Area, though with less intensity. These smaller quakes contributed to the region's ongoing pattern of seismic activity, reminding residents and officials alike of the constant movement beneath their feet. Seismic activity, statistics, and notable earthquakes. March 2025. The month of March 2025 proved to be active for the San Francisco Bay Area in terms of seismic events. Volcano Discovery reported that in the 24-hour period surrounding these key earthquakes, at least one quake of magnitude 1.0 occurred. Over the course of the week, the Bay Area experienced 3 earthquakes measuring magnitude 3.0 or higher and 11 quakes ranging between magnitudes 2.0 and 3.0. Additionally, 19 smaller tremors registered below magnitude 2.0, which are typically imperceptible to the average person, but are significant for seismologists who track patterns and stress levels along fault lines. Looking at a broader time frame, Earthquake Track recorded 49 earthquakes of magnitude 1.5 or greater in the previous 30 days. Over the course of the past year, the Bay Area experienced a total of 385 earthquakes of magnitude 1.5 or higher. These statistics underscore the ongoing seismic activity in the region and reinforce the importance of monitoring even minor tremors as indicators of potential shifts in tectonic stress. Among the other notable earthquakes in March 2025, a 2.9 magnitude event struck near Walden, California on March 17th at a depth of 16 kilometers. Just days earlier, on March 14th, a 1.6 magnitude earthquake occurred near Portola Valley, California, at a depth of 6 kilometers. On March 13th, a 2.3 magnitude quake shook Concord, California, with a depth of 12 kilometers. Though none of these smaller tremors caused damage, they contributed to the cumulative stress release along the various faults traversing the Bay Area and highlight the interconnected nature of seismic activity throughout the region. Historical context and future outlook. The San Francisco Bay Area stands as one of the most earthquake-prone regions in the United States, a reputation grounded in both scientific fact and historical experience. Positioned along the dynamic boundary between the Pacific and North American tectonic plates, this region endures near constant geologic stress, which often results in seismic activity. Since formal record-keeping began in 1836, the Bay Area has experienced at least 5 major earthquakes that registered at a magnitude of 6.75 or higher. These seismic events have left lasting impressions on the landscape and the communities affected, highlighting the destructive potential that lies beneath the surface. EarthquakeSafety.com points out that historical patterns reveal a persistent and measurable risk for future large-scale earthquakes in the Bay Area. Statistically, there is approximately a 50% chance that another major earthquake, comparable in magnitude to those historic quakes, will strike within the next 30 years. This forecast emphasizes not just the inevitability of a major seismic event, but also the necessity for long-term preparedness, especially as the region's population continues to grow and urban development intensifies. The increasing density of infrastructure and housing makes it even more critical that city planners, engineers, and residents commit to improving structural resilience, upgrading building codes, and investing in disaster readiness initiatives. Recent seismic events, including the 3.7 magnitude earthquake off the coast of San Francisco on March 10, 2025, and the 3.9 magnitude quake near Dublin on March 17, 2025, caused no damage or injuries. However, their significance should not be understated. These minor tremors serve as stark reminders of the geologic forces at play beneath the Bay Area. Experts consistently caution the public against assuming that such smaller earthquakes act as clear warnings for larger quakes. The scientific community remains divided on whether small quakes can reliably predict larger ones, but they do agree that each seismic event represents an adjustment in the Earth's crust, an indication of the ongoing stress and potential for future rupture. In this sense, any earthquake, regardless of size, could be part of a broader seismic sequence that might eventually culminate in a major event. News outlets play a vital role in keeping the public informed about seismic activity. Reputable sources, such as the San Francisco Chronicle, SF Gate, and CBS News, provide timely and accurate updates when earthquakes occur, often within minutes of a tremor. These reports typically include data from the United States Geological Survey, USGS, as well as first-hand accounts from residents. Such information helps residents understand the magnitude, epicenter, and potential impact of each event. Meanwhile, scientific platforms like Earthquake Track provide real-time data and visualization tools that allow both researchers and the general public to monitor patterns of seismic activity. These monitoring tools are essential for emergency management officials who rely on up-to-date information to make decisions about public safety, infrastructure inspections, and potential disaster response. Ultimately, while the Bay Area's frequent small quakes might not cause immediate concern, they serve as critical reminders of the region's seismic reality. The Earth is always moving beneath the Bay Area, and with every tremor, the need for awareness, resilience, and preparedness grows. Preparedness and safety. Measures for Bay Area residents. Given the Bay Area's heightened seismic activity, local governments and emergency services consistently encourage residents to prepare for earthquakes well in advance. One of the most critical steps involves developing a comprehensive emergency plan. Families should ensure that all members understand what actions to take during and after an earthquake, including where to meet and how to communicate if phone lines are disrupted. In addition to planning, residents should assemble emergency kits containing essentials such as bottled water, non-perishable food, medications, first aid supplies, flashlights, and batteries. These kits should be easily accessible and regularly updated to ensure they remain effective in a crisis. Securing heavy furniture and household items is another vital safety measure. Anchoring bookshelves, televisions, and appliances to walls helps prevent them from toppling during a quake, reducing the risk of injury and damage. Similarly, installing latches on cabinets and drawers can keep contents from spilling out when the ground shakes. Staying informed is equally important. By utilizing resources such as the USGS's Earthquake Map, Earthquake Track, and local news platforms, residents can receive timely alerts and updates about seismic activity. Many smartphones now come equipped with emergency alert systems that notify users of nearby earthquakes seconds before the shaking begins, offering precious moments to take cover. Alright, so that's it for this video, and if you want to watch more amazing content like this, check out some of our other videos. Bye!